Hi students, in the previous video we see about the various registers present in the PLC. So what are the various registers present in the PLCs? Input registers, output registers and holding registers. So in this video onwards we will see about the PLC functions. So various PLC functions are timer functions, counter functions, arithmetic functions, number comparison functions and number conversion functions and data handling functions, sequencer functions and matrix functions, etc. So in the third unit we have four functions are there, five functions nearly: timer function, counter function, arithmetic functions, number conversion functions and number comparison functions. So in this video I want to teach about the timer functions and counter functions. So what is the need of the timer function means if you want to delay any operation for some time, if you want to delay the operation for some time, then we go for the timer function. So the timer function syntax, basic syntax is this one, in this one. That means here in001 is the contact. If you make make on in001, then the timer will be starts. So suppose we set the timer value as 4 seconds, then there will be one disadvantage of the front. That means the timer setting time is suppose 4 seconds, and if you make the in001 is on and the operation will be running, that means the output ts017 will be on after 4 seconds. But if any reason the in001 is off, then the timer will be also be off, and when the power is again on, then this in001 is again on, then the timer not starts from 2 seconds. That means up to now the timer will be working for 2 seconds and suddenly power goes on. So as the power goes on, the input 001 contact is off. So now we realize that the in001 contact is off, so we make that on, then the timer working for 4 seconds, not for 2 seconds. Already 2 seconds is over, so not for 2 seconds, it can be worked for 4 seconds. So before 2 seconds and now 4 seconds, total 6 seconds it will be operated. So the timer function delay we have to provide is 4 seconds, but because of the in001 interruption, the timer will be makes on for 6 seconds. So this is the disadvantage of considering this syntax. So because of that reason we can go for we can modify the timer function syntax. So how means in this manner, that means one run input and one enable or reset input. So the timer is also normally represented in two ways, that means block format and coil format. So most of the cases we prefer for block format only. We cannot realize or analyze the coil format in our discussion throughout the chapter, throughout the subject. So I can teach the only block format only. So this one is the in0 syntax. I am explaining the syntax for the block format of the timer function. So this when we press the run input in001, and we can preset the timing delay value for 14 seconds, and the output of the ts017 is on after 14 seconds, where we give the 14 seconds in the holding register 101. So we set the timing value as 14 seconds, but for any reason we operate the timer function for 6 seconds, and for any reason this input in001 is off, in001 is off, then this in002 is the enable input. We already make it on the in002 input. So even the power is off, then the timer stops its operation at 6 seconds because of this enable input. If there is no enable input and if the power is again on, then the timer will be resets to 0. That means already 6 seconds work will be completed, and again 0 means that will be again another 14 seconds. So 14 seconds plus 6 seconds, totally we may use 20 seconds. That may be somewhat problematic to that particular operation. So that's why we can provide the enable or reset input. So if this contact is closed, then that is the meaning of enable, and if the contact is open, then that is the meaning of reset. That is the meaning of the reset. So by using this contact, we can make the timer function value at that particular time only. At whatever the time that timer will be stopped, that value will be maintained by the timer. However, the coil format with the separate enable and reset will also be represented here. Here, what is the difference means? Here, the single contact can be used as the enable or reset, but here, the for enable we consider one contact, and for reset we can consider the another contact. That is the difference only. So the industrial application for the timer function is, so many industrial applications are there, but our John W. Webb explains the one function, that one on operation. That operation is nothing but hardening of the metal. Hardening of a metal. So what is the process involved in this hardening of the metal means, in the similar fashion of the drill press operation and spray process control. So here also we have three switches. So one is master on and master off, and another one is right up and right down, and another one is left up and left down. That means start, right start and right stop, and right left start and left stop, like that. So what is the procedure means, first we press the master start on button, then we place the part which can be we want to make hardening. We can place the part on the this mandrel, and because of the gravity or spring control or pneumatic air control, the mandrel will be moved to the upward direction. When after placing the part on the mandrel, then there will be one sensor. The sensor is nothing but limit switch part in place PP, and we can press the both the up buttons. That means right start and left start. That means right up and left up. Then by placing the part on the mandrel, and by pressing the right up and left up, then the mandrel will be moved to the upward direction. And when the part reaches to the topmost position, then the LSU sensor will be activated, limit switch up will be activated, and when the limit switch up switch will be activated, then the particular part will be heated for 10 seconds and cooling for 6 seconds, and after 1 second the system will be reset. This is the procedure. So here what we do means, we can make the hardening of a metal. So how we can make the metal as hard? We can heat the metal and we can cool the metal. Then any voids present in the inside the metals are vanished by heating and cooling and heating and quenching. So that particular metal maybe becomes as a very hardened metal. So I once again telling the what is the process involved in the hardening of the metal with the help of the PLC timer function is, we have three types of switches: master on and master off, and right to start and right to stop, and left start and left to stop. Here we can represent the right up and right down, and the left up and left down. So first we start the master start button, then we place the part on the mandrel. So when we place the part on the mandrel, then one sensor will be activated. That sensor is nothing but LSPP, limit switch part in place. And after placing the part on the mandrel, that means after activating the LSPP sensor, then we can press the right up button and left up button. So with these buttons, the mandrel will be moves towards the upward direction. And when the mandrel reaches the topmost position, there we have another sensor. That sensor is nothing but limit switch up. So when the limit switch up sensor will be activated, then that particular object will be heated for 10 seconds and cooling for 6 seconds. And after 1 second, the system will be reset and the mandrel will be comes to the downward direction. So the object also comes to the downward direction. The object also comes to the downward direction. So this is the process involved in the timer industrial applications. So here we can differentiate the what are the inputs and what are the outputs. Let us see. So here inputs are master start button 002, master stop button 001, and left start and the left start 4, and left stop 3, and right start 6, and right stop 5, and limit switch up 7, and limit switch up 8, and limit switch down 7, and the three outputs we consider. What are the three outputs? Solenoid value up, and heat on contactor coil, and quench the spray water solenoids. Another optional is there. We cannot consider. Those are the very important considerations. So coming to the ladder diagram, let us see. These two are for run purpose and light purpose only, 0017 and 0018. So that's why I am not telling as those are the exact outputs. So here first we can press the master start button. So when we press the master start button, then definitely we can have the IN002 contact is on. So this IN002 contact is normally open. So when we make it on, then this normally open contact can be acts as a normally closed contact. Then there will be a path for the output, that is CR017. That CR017 indicates system on. And wherever the CR017 is there, their contacts will be also on. That means if the contacts are normally open contacts, they will be acts as a normally closed contacts, and if the contacts are normally closed contacts, then those will be act as a normally open contacts. So here here we have CR017 and CR017. These two are normally open contacts itself. So when we make it on, output on, then these two contacts can be acts as a normally closed contact. So this contact will be closed, and at the same time this contact will be closed. So when this contact will be closed, then even though we remove the master stop button, then also the system will be on. So here CR017 on, and IN003, IN005 indicates the stop buttons. These are also on, and we place the part on the mandrel. So when we place the part on the mandrel, then one sensor will be activated. That sensor is nothing but LSPP, limit switch part in place. So when the limit switch part in place sensor will be activated, then the limit switch part in place can be represented with the input to IN007. IN007. So when IN007 is on, and when we press the left start and right start, then IN004 and IN006 also on. So CR017 is already on, IN003 is already on, and IN005 is already on. We can make these three as on. So we can provide the path for the output CR018. So when the CR018 is on, this contact is also closed, and this contact is also closed. So when the CR018 will be on, then the CR019 will be also on. CR019 means the up movement of the mandrel. What is that? Up movement of the mandrel. So this mandrel will be goes to the upward direction, and when that reaches the top position, then at the top position we have the one sensor. That sensor is nothing but LSU. LSU means limit switch up sensor. So that indicates by the IN008. When IN008 is on, CR18 is already on. So this contact is also closed, and this contact is also closed, and this contact is also closed. That means the for heating timer, for cooling timer, and for the shutdown timer, for three timers, here we have the three timings: 10 seconds, 8 seconds, and 1 second. For these three timers, the enable input is on. CR18 is on, CR18 is on, CR18 is on. Just we have to, if you make the run input is on, then the particular timer will be work. So first, our first case, when the LSU is on, limit switch up sensor will be on. Then IN008 is on. Then this timer will be starts working and generates the. So here CR18 is closed and IN008 is closed. So this line will be provides the path for the CR021. That the CR021 is nothing but heating of the metal. So this heating will be continuously goes on. So after 10 seconds, this CR020 contact will be on. After 10 seconds, the output of the timer will be on. So what is the output of the timer? CR020. So CR020 will be on. So when the CR020 will be on, then wherever the CR020, those contacts will be on. That means normally open contacts can be converted into normally closed contacts, and normally closed contacts can be converted into normally open contacts. So here CR020 we have, here CR020 we have, and here CR020 we have. So here CR020 is a normally closed contact. So this one can be open, can be acts as a open contact, and at these two cases that can be acts as a closed contact. So when Cr020 is open contact here, then the heating will be stopped. The heating will be stopped and this timer starts working. Second timer, which having the preset value as 8 seconds. This timer starts working and generates the output after 8 seconds. The output of the timer is CR022. So CR20 is on. CR22 is a closed contact. So this line will be activated. This line activated and generates the one output. That output is nothing but CR023. CR023. So when the CR023 is on, then what happened? Quenching of the metal takes place. That means cooling of the metal takes place. So first 10 seconds we make heating and now cooling we done. So CR023 is on, cooling will be takes place. So at what time the timer will be works for the 8 seconds. So after 8 seconds CR022 is on. So when the CR022 is on, then wherever the CR022 is on, all the contacts are on. That means the normally closed contact can be acts as a open contact and open contact can be acts as a closed contact. So here we have the closed contact, so that can be acts as a open contact. So when we acts as a open contact, then CR023 is off. That means quenching is off. So cooling also stopped. So CR22 is on. That means this timer will be starts. So when this timer will be generates the output on after 1 second. So after 1 second, CR024 will be on. So when CR024 will be on, here we have the CR024 contact. So that will be on. So that contact is normally a normally closed contact. So when we make it as on, then the normally open contact, normally closed contact can be acts as a normally closed contact. So there is no path for CR018. So if there is no path for the CR018, then there is no path for upward direction. So the system will be reset and the mandrel which is present at the top position will be comes to the downward position. So this is the operation involved in the timer function and PLC ladder diagram, and this one is the connection diagram. So that entire program will be sent to the PLC CPU, and that PLC CPU we have the both input modules and output modules. For input modules we connect the input devices, and for output modules we connect the output devices. So what are the input devices connected to the input modules are master start and master stop, and left start and left stop, and right start and right stop, 6, and LSU and LST. Totally 8 inputs are there. And what are the outputs? System on and run, up solenoid and cooling and quenching. So these are the 5 outputs. So this is the connection diagram for the PLC quenching of heating and quenching of a metal operation. And next one is the counter function. So we will see in the next class. Thank you.